class.
And I'm Nabil Dihyar, Miss Mukherjee's 8th period class.
And this is our physics presentation.
On Newton's first law of motion.
Alright guys, it's Patrick of the John Champ High School golf team. John Champ High School. John Champ High School. John Champ High School. Alright, I'm going to be demonstrating a physics presentation on Newton's first law. Right here we got a golf ball at rest. I'm going to put it in motion. Alright, so we know that was a lot to take in, but we're going to simplify it for you.
We're going to be using the basketball to represent the golf ball at top.
Here we have the golf ball that I just hit, sitting on a tee, at rest.
And a tee exerts normal force, and the gravitational force is what pushes it down from the top, and it pushes it down.
Alright, it's also important to be noted that right now, it's balanced, as the newtons on the top of the gravitational force, which is pushing it down, keeping it down, are the same as the newtons of the normal force, which is coming up. Alright, so here we have my golf club hitting the ball. Alright, so there's a new force that was introduced when Nabil just did that.
That new force that was introduced is called the applied force.
It's a leftward force that comes from my club, and it goes this way. Alright, so now we have the ball in air.
So when the ball is in motion, you have an applied force going to our left and also up. And in the opposite direction, you have air resistance. And then, as usual, you have gravity. So you have gravitational force acting.
Alright, so now the ball's still in air, and now it's coming down, and it's slowing down, and friction is introduced.
So applied force is still in action on our left, and going up is normal force, which is now introduced since the ball is on the ground, so there's no more applied force anymore. And on the right side we have friction, so to our right we have friction introduced because once it hits the ground, friction is needed to stop the ball, and we still have gravity, so gravity is still acting downwards in the ball.
So now the ball is back at rest.
And normal force is acting upwards while gravitational force is still acting downwards.
There's no other forces anymore. Hole in one. Alright, so here is a free body diagram of the golf ball at rest on the tee.
And acting upwards is normal force, which is exerted by the surface. And we also have gravitational force, which is also weight, and it's acting downwards.
It's also important to be noted that normal force is always perpendicular from the Alright, so here we have a free body diagram of when I hit the golf ball with my golf club, the impact of it.
So a new force that is introduced is the applied force, and in this case it's the push that the golf club made on the golf ball when Pathiam.
Alright, so now here's a free body diagram of when the ball was in air and it was just going 700 yards because I'm just really big.
So when Pathiam hit the ball at an angle, which means that the applied force is acting upwards as well as going to the left. So this is why we have applied force on these two sides. And we also have air resistance, which is acting opposite of the object.
Alright, so here we have a free body diagram of when the ball made contact with the surface and was slowing down, gradually getting closer to the hole. And here we have the normal force, which is back in action as it hit the surface. And a new force being acted on the object is friction. And it, just like air resistance, it opposes the motion of the object, and it's always parallel to the surface.
You right?
Alright, so here we have the last free body diagram, and it's the ball in the hole, because I only make hole-in-ones, you know how it is. And here we have the normal force applying up, and the gravitational force going down, just like always. Normal, gang.
Okay, so here are important formulas you need to know for Newton's first law of motion.
Thank you for watching, guys.
I'm Miss Busky and I approve of this project.